Hi everyone, welcome to goclasses. In this session, we are going to solve GATE previous year questions from this topic Relational Algebra in DBMS. So let's start with this question. This is GATE 2024 question. Consider the following relations are AB as AC. So you can see two instances are given to you, two relations are given to you. These are the two tables R, S. The number of tuples obtained by evaluating the following expression. This relational algebra expression is given to us, and the question is asking that how many tuples will be there in the output. Okay, when you evaluate this relational algebra expression, then how many tuples will be there in the output? So this is a very easy question. Let's solve it. You can see this inner expression. Look at this expression. This expression is basically R. Then we have join operation. Okay, then we have this join operation, and we have here r dot a is equal to s dot a. First you tell me, is this natural join? First you tell me, is this natural join? Look at this inner expression. Basically this inner expression, you tell me, is this natural join? Let me know. No, this is not natural join. This is basically your theta join, or I can say this is your eq join, because there is equality operation here. Okay, so you can call it eq join. Remember, this is not natural join, because when we write natural join symbol, then we don't write any condition with it. Okay, so because remember, natural join does not come with any condition. Okay, so actually let me tell you one thing. If you do natural join, then basically we will be checking equality of attribute A. Do you agree with me? Because this is the common attribute in R comma S. This is the attribute with the same name. So basically if you perform natural join, then also we will check the equality of common attribute. Then also we are going to do this, but we will not explicitly write this condition. So that is the difference. Remember, this is eq join. This is eq join, or you can say this is your conditional join. This is your conditional join. Okay, and remember, what will be natural join? The natural join will be without any condition. We don't write any condition when we are writing natural join. Okay, so this is a natural join. Now internally, remember, internally we will check the equality of attribute A. Okay, so internally the same thing we will do. We will check the equality of attribute A. But remember, in the natural join we don't write any condition. You can see this is the natural join symbol, and this does not come with any condition. Okay, now let me tell you the difference. What will be the difference between this result and this result? Okay, because here also we are checking the equality of attribute A. Okay, here also in the natural join also internally we will check the equality of attribute A. Then what is the difference? Where is the difference? The difference is in the schema, in the output schema. So here, if you see the output schema of natural join, then remember, this attribute A we will write only one time. Okay, in the output schema of natural join, this attribute A we will write only one time. So this will be like ABC. Okay, because this common attribute we will write only one time. So this is the output schema of natural join. And what will be the output schema of eq join? What will be the output schema of this conditional join? So here let's see the output schema. Output schema, the output schema will be, all four attributes will be there. Okay, it will be like this: r dot a, b, s dot a, c. Okay, c. So like this. So this will be your schema. Is this clear? So there will be four attributes. Remember, r dot a, b, s dot a, c. Okay, so this is the difference between these two. I hope you understood the difference. Okay, now let's see. So this is your conditional join. What will be the output schema? Okay, this internal expression, you can see this expression. This is our conditional join, or I can call it theta join. Okay, you can call it theta join, or you can call it conditional join. Conditional join. Okay, so let's see what will be the output schema. The output schema will be, there will be total four attributes. That will be r dot a, b, s dot a, c. Okay, so this will be the schema. Okay, now you tell me, how many tuples will be there when you evaluate this expression? Then how many tuples will be there? Remember, this is the condition, r dot a equal to s dot a. Okay, so you can see the equality of a, the equality of attribute A we are checking. So this tuple will match with this tuple, yes or no? Okay, I can say that this tuple it will match with this tuple. Okay, because here value is 10, here also value is 10. Okay, so we will get this 10, 20, 10, 90. Okay, so this tuple we are going to get. Okay, what else? You can see this tuple, this will not match with any tuple here, right? Because here value of a is 20, here there is no value of a 20. Okay, next you can see this tuple, because here value of a is 30, so this tuple will actually match with this tuple. Okay, so you can see this tuple will match with this tuple. Also you can see, also we can see that this tuple will also match with this tuple. Okay, so you can see this tuple will also match with this tuple. Okay, very simple, right? So basically two tuples we are getting. You can see 30, 40, 30, 40, 30, 45. Okay, next we are getting 30, 50, 30, 45. Okay, so these three tuples we are getting. Next you can see this tuple will not match with anyone, because here a value is 50 and here there is no a value 50. Okay, so this is the result. Three tuples we are getting. Okay, very simple. Now what we need to do? Now the next is we select from this. Remember, now on this what we do? Now on this we are going to perform. Remember, we are going to select tuples. Okay, we are going to select tuples where value of b is less than value of c. Okay, so this is what we are going to do now. We are going to select tuples where value of b is less than value of c. So now what will happen? Value of b must be less than value of c. So finally I can say this tuple will be rejected. Yes or no? This tuple will be gone. So the remaining two tuples will be there in the output. So finally I can say the number of tuples in the output, that will be, answer will be two tuples. Okay, is this clear? Very simple question. Now let me tell you one thing. In the gate exam, actually you don't even have to draw the table. You don't even have to write the table. Let me tell you, you can solve this question without taking copy pen. Without taking copy pen, you can solve this question. Okay, what you can do, you can just look at the table r comma s. What we are doing the join here. Okay, and equality of attribute a we are checking, right? Correct. Okay, so very simple, we are joining r comma s, this table r, this table s, we are joining that. And you can see we are checking the equality of attribute a. So here it is very simple point, that this tuple it will match with this tuple. So one tuple you will get this. This is your tuple number one. I can say let's call it tuple number one, t1. Okay, next which tuple you will get? Next you can see this tuple, this 30, 40, this tuple will match with 30, 45. Okay, so this is the next tuple we are getting. Remember, this is the next tuple we are getting. Okay, so let me call it tuple t2. And you can see this 30, 50, this tuple will match with 30, 45. So here the next tuple that we are getting, that will be, okay, that is like this. So this is the next tuple that we are getting. Correct? Okay, so let me call it tuple t3. So that's it, very simple. This tuple will not match with anyone, because here a value is 50, here there is no a value 50. Similarly, this tuple will not match with anyone. Okay, so finally I can say, when you execute this in this inner query, then you are going to get three tuples. Those are t1, t2, t3. You can easily see without taking copy man, you can solve this question. Then from these tuples, from these three tuples, remember, we want to select those tuples where b value is less than c value. So tell me, in this tuple t, in this tuple t1, b value is less than c value or not? Yes, b value is less than c value. Okay, correct. Okay, b value less than c value. Next, what about t2? What about t2? In this tuple t2, b value is again less than c value. Okay, what about t3? What about tuple t3? In t3 you can see that b value, you can see in t3 b value is 50 and c value is 45. So b value is not less than c value. B value is not less than c value. So that's it. So finally I can say, in the final output, this tuple will be selected. T1 and T2, they will come in the final output. Okay, so finally I can say that the number of tuples in the output, that will be 2, and these two tuples will be, I can say, t1 comma t2. These two tuples will be in the final output. Okay, that's it. So very simple question, I hope you understood. Now let's move on. Let's solve this GATE Data Science and Artificial Intelligence 2024 question. So this is GATE DA. DS&AI 2024 question. Let's solve it. This is a very beautiful question, let me tell you. Consider the database that includes the following relation. Three relations are given to us: defender, forward, team. Okay, so these are the all the defenders, these are all the forward, and these are the players which are in the team. Okay, these are the players which will play the team or which will play in the match. Okay, so like that you can understand. Now the question is saying, which one of the following relational algebra expression checks that every name occurring in the team, every name occurring in the team means this every name occurring in this table appears in either defender or forward, where this phi, this is empty set. Okay, so these are the queries that are given to us. Now let's solve it. First of all, before solving this question, let me tell you one thing, that this operator is this division operator. Look at this operator. Look at this operator. Is this division operator? Look at this. See, in every option we have this operator, right? Okay, you can see this operator we have. Tell me, what is this operation? Is this division operation? No, this is not division operation. Okay, division operation is like this, or division operation is like this. Okay, this is division operation. Remember, when you write like this is division operation, and this is your set difference. This is same as your set difference. This is your set difference operation. Okay, so this is standard symbol for set difference. We have already seen this in the set theory lectures. Okay, so you may already know this, that this is your standard operation, or I can say symbol for set difference. So I hope this point is clear. Okay, so remember this point, that this symbol, either you can use this symbol or you can use this symbol for set difference. For set difference. So when I say R, this simply means R minus S. Okay, this is a set difference, and it will be those values which belong to R but not belong to S. Yes or no? What this will do? This will give you those values which are in R but not in S. Okay, those values which are in R, okay, and not in S. They should not be in S. It's simple, very simple. If this is R, this is S, then I can say these values which are in R but not in S, these values are your R minus S, or I can say these are R minus S. Okay, so this is a symbol, remember, for set difference. Okay, and remember, this symbol is for division operation. Okay, this is the symbol for division operation. So in the options, remember, we don't have division operation, we have a this is set difference operation. Okay, now very simple to solve this question. This is very simple. See what the question is saying. The question is saying that in the defender table, okay, in the defender table there is name. So these are the names of defenders, and there is a forward table. In the forward table also we have names. These are the names of forward, okay, players who are forward. And next I can say this is team. Here also we have name, so you can assume that these are the players in the team. Okay, the players who are chosen in the team. Okay, so like that you can understand. So these are the tables. Now the question is asking, please understand, the question is asking which relational algebra expression, which expression checks that every name occurring in team appears in defender or forward. Okay, means every name which is here, that should be either here or both. Okay, or both. Is this clear? Okay, so remember, by default when you say either or, here you can see either or, by default either or is inclusive. Okay, when you say by default, when you say either or, please understand, when we say either P or Q, okay, that by default that is inclusive, means either that should be in P, or that should be in Q, or that should be in both of them. Okay, is this clear? So by default, remember, either or, that is same as inclusive, means P or Q or both. Okay, is this clear? So very simple point. So this is your either or. So by default either or is inclusive, means either that should be in P, or that should be in Q, or that should be in both of them. Okay, very simple. Now what we want that everyone who is in the team, that should be here or in both of these tables. Okay, so this is what we want to make sure. Then tell me how to make sure this. Very simple. This is actually very simple. Every person who is here, okay, that should be here or here. Remember, there can be extra people here. Okay, there can be extra people here. For example, let's assume, let me give you cricket analogy. Okay, if you are fan of football, then you can use this analogy, or if you are a fan of cricket, then you can use this analogy, that let's assume these are the batsmen. Okay, and let's assume these are the bowlers, and let's assume this is the team, this is the final 11. Okay, this is the final 11. Okay, is this clear? Final 11 means the final team. Now you can easily see what we want. We want that in this team everyone should be either batsman or bowler. Okay, or that can be all rounder also. For example, here you can have some person who is batsman also and bowler also, that is also fine, that is allowed. Here you can have B, which is batsman, here you can have C, which is bowler. So all these situations are fine. Okay, but this should not happen that you have someone in the team who is neither batsman nor bowler. Okay, this should not happen. Okay, this should not happen. So this is what the question is saying. Question is saying that everyone who is here, that should be either here or here. Is this question clear? Please tell me. First, you tell me, is the question clear? Remember, this type of situation, we do not want that you have someone in the final team who is neither here nor here, who is neither bowler, who is neither batsman. Yes or no? Neither batsman nor bowler. So this type of situation we don't want. Means if you have someone in the team, then that should be either batsman or bowler or both. Okay, very simple. So I hope this point is clear to everyone. Now let's see how to make sure this. Now making sure this is very simple. What I can do from the names. Okay, here I can find the names. Okay, from the names of the team in this table team, I can find the names. Okay, let me find all the names from the table team. Now if I remove the names which are here, then what should I get? Tell me. If I remove the names which are in the union defender union forward. Okay, means I find the names, union of names. Basically, I find the names in defender, names I find, union forward, names I find. Okay, so from these names, I can say from the names which are here, if I remove these names, then what should I get? I must get empty set. Do you agree with me? I must get empty set. Okay, I must get empty set, because remember what we want. Please understand what we want. We want that everyone who is in the team should be here or here. Yes or no? So everyone who is here, from that, if I remove these names, then I should get empty set. Okay, yes or no? I should get empty set. So if I am getting empty set here, that simply means that everyone who is in the team, that is either here or in both of them. Okay, is this clear to everyone? Please tell me. So what will be the answer? You can easily see that answer will be option C. Yes or no? Option C is the answer. You can easily see in the option C that first we are finding the names from the team. From this table, we are finding the names. Then we are doing minus. Then we are doing minus. Okay, and we are subtracting the names which are in the union of these two tables, and that should be empty. Is this clear? Let me know. Okay, so let me just make it clear. See, in the team table, let's assume you have these names. Okay, the names I'm finding, let's assume in the team table you have these names ABC. Now what we want to make sure, we want to make sure that these names are in defender or forward or both of them. Yes or no? So let's assume in the defender I have these names. Okay, and in the forward I have these names. So let's assume that in the defender I have these names. A is defender, and let's assume some person D, E, they are also defender. In the forward, let's assume A is forward also, and let's assume B is forward. Okay, and let's assume here this C is defender. Okay, so let's assume, and there is some person E here. Now you can easily see, tell me, is everyone who is in the team that is defender or forward, can I say? Yes or no? Everyone who is in team, you can see that is either here or here. Okay, you can see this A is in both of them, that is fine. B is here. Okay, C is here. Okay, so this is fine. Now you can easily see what will happen. Tell me, what should I do? Should I do the union of this minus this, or should I do this minus union of them? Tell me what should I do? Means I am asking you. So let's assume, let me call it, okay, for a moment, let me call it T, let me call it D, and let me call it F. Okay, let me call it capital F. Okay, and let me call it T, and I'm calling it D. Now you tell me, let me know. So I want that everyone who is here, that should be here or here. Then what should happen? Very simple. T minus D union F. That should be phi. That should be phi. Okay. So that should be phi. Because remember, a very simple point, let me tell you. Okay, just note this. You know that this is, if this is R, this is S, then what is R minus S? You know this is R minus S. Those elements which are in R but not in S. Okay, now you tell me, if R minus S is phi, then what will happen? If R minus S is phi, then what it means? Let me know. Then what it means? It means every element of R is in S. Yes or no? If R minus S is phi, if R minus S means this area is phi, means this area is phi, this area is a phi. Do you agree? If R minus S is phi, means this area is phi, this area is phi, this area is phi. Now you can see this is R, means R is subset of S. Okay, yes or no? So if R minus S is phi, then I can say R is subset of S, which means every element of R is in S. Okay, which means every element of R, element of R is in S. Is this point clear? Please tell me. Let me know. So remember, this is an important point, that if you want to make sure, to make sure, to make sure that every element of R is in S, every element of R is in S. If you want to make sure that every element of R is in S, then what you should do? Then remember, R minus S must be phi. Okay, so this is the concept. See, the concept is actually very simple. If you want to make sure that every element of R is in S, then this should happen. R minus S must be equal to phi. Okay, you can easily see. Because what is R minus S? That is those elements which are in R but not in S. So these elements are R minus S. This is R minus S. Now, if this R minus S is empty, means there is no element here. Means there is no element here. Means there is no element here. If there is no element here, then this is your R. Now you can see R is subset of S. You can easily see R is a subset of S. Okay, so I hope all these points are clear to everyone. So that's it. So finally, this is a note. Let me tell you, this is a note, that this is if and only if, that this is if and only if R minus S is equal to phi, if and only if and only if R is a subset of S. Okay, is this clear? The same thing I can also say like this, that R is subset of S if and only if and only if R minus S is phi. So basically, this gate exam question, this gate 2024 question, that is based on this fact. Yes or no? That is based on this concept. Is this clear? Please tell me. This concept is clear to everyone. Let me know. Is this concept clear to everyone? Very simple concept. If you want to make sure that every element of R is in S, then R minus S must be equal to phi. Now, what the question is saying? Question is saying every element of team is here or here. Yes or no? This is what the question is saying. Question is saying that every element of T is here or here. So let me write it so you can see that what we have. The question is saying, okay, the question is saying that every element of team, every name in team is in defender or forward, is in defender or forward. Okay, this is the question. Now you can easily see. First of all, tell me every name in team is in defender or forward. What this means? Defender or forward. Or means union. Do you agree? Or means union. Okay. So every name in team that is in defender or forward, that means in that is union. Now every element of team is here then what should happen? Every element of R, this is like R and this is like S, every element of R is in S. Then what should happen? R minus S should be phi. Yes or no? This is what should happen. So the same thing you can say here, that every name in team is here. Okay, then what should I do? Very simple. You find the names from team and then you minus this union. Okay, and the result must be phi. Okay, what you are subtracting? You are subtracting names, union of names, because or means union. So I hope this concept, this question has become very clear. Please tell me, did you understand? Let me know. Let me know, is this clear to everyone? This is the concept. This question is based on this concept. I hope you understood. This is a very simple question. I hope you understood. Okay. Now let's see the other options, what they are making sure. Tell me what other options are making sure. So remember, the answer will be option C. We found the answer. The answer is option C. Now you tell me what the remaining options are telling us. Can you tell me? Let's do the analysis of the remaining options. Tell me about the remaining options. What option A is saying? Please tell me. You tell me about option A. What option A is making sure? Anyone? Let's do the analysis of option A. You tell me about option A. So let's see option A. What option A is saying? Tell me. In option A, you can see from team, we are subtracting the intersection of defender and forward, and that is phi. What it means? It is like from team, you are removing intersection of defender and forward, and that is phi. What it means? It means every element here is here. Okay, please understand. This is very simple. This is very simple. Please understand what I am saying. See, for a moment, assume this is R. Assume this is R. Assume this is S. R minus S is 5. What that means? Let me know. R minus S is 5. What that means? R minus S is 5. What that means? That means every element of R is in S. Yes or no? That means every element of R is in S. Okay. So you can see every element of team is here. Okay, every element of team is in the common part. What it means? It means every element of team is defender as well as forward. Means this is the team of all rounder. Can I say? It's like everyone is all rounder. Yes or no? Because every element of R is in S. Okay, every element here, that is here, and here we are taking the common elements. So I can say that every element which is here, that is here also, here also. So every element which is in team, that is defender and forward. Okay, so I can say, remember, I can say that option A, basically option A is checking. What option A is checking? What option A is checking? Let's remove the remaining options. What option A is checking? Let's see that. Option A is checking and. Okay, option A is checking and. So here I can say and. That's it. Okay, option A is checking and. So here you write and. Okay, that's it. This will be your answer. This is what option A is checking. Option A is checking that every name in team appears in defender and forward. Is this clear? Let me know. This is what option A is checking. Is this clear? Let me know. So very simple. What option A is doing? Option A is checking that every element which is in team, that is here and here. Okay. Basically, every element which is in team, that is defender as well as forward. Okay. So this is what option A is checking. That's it. This is the analysis of option A. What about option B? Tell me what option B is doing. Let me know what option B is checking. Tell me what option B is checking. So let's see about option B. Option B is basically saying that from the common, from the all-rounders, you remove the team, then you are getting phi. It is like this. Okay, from the defender, intersection, forward, from this you remove team, then you are getting phi. Okay, so again the same thing. Assume this is R. Assume this is S. R minus S is phi. What that means? Tell me. R minus S is phi. What that means? That means R minus S is phi means every element of R is in S. Okay, means R is subset of S. Okay, yes or no? So remember, these are the all-rounders. Do you agree with me? See, what is the intersection? The intersection means all-rounders. So this is your basically all-rounders. These are all the all-rounders. Can I say? Can I say these are all the all-rounders? From all the all-rounders, you remove the team, you are getting phi means every element of R is in team, means every all-rounder is in team. So what option B is checking? Option B is checking that every all-rounder is selected in team. Every all-rounder of the country. It's like this, that every all-rounder has been selected in the team. Is this clear? Every all-rounder has been selected in the team. You can think from the cricket point of view. Okay, from the cricket point of view, these are the batsmen, these are the bowlers. Okay, so what is their intersection? Their intersection is all rounders. Now from the all rounders, you remove the team, you are getting phi. R minus S is phi. That means R is subset of phi. Means every all rounder has been chosen in the team. So what option B is checking? Remember, option B is checking. Option B checks that every all rounder has been selected in team. Every all rounder, every all rounder has been selected in team. Has been selected in a team. Is this clear? Every all-rounder has been selected in team. There can be extra person, remember. In this team, you can have extra people. For example, let's assume A, B are all-rounder. In this team, you can have A, B, C, D. You can see every all-rounder has been selected. There can be extra people. Okay, there can be extra people. Because remember, R minus S. R minus S is phi. That means R is subset of S. S can have extra people. Okay, is this clear? This is S, this is R. So every element of R is in S. S can have extra people. Okay, very simple. So this is option B. So what about option D? Tell me. What can you say about option D? Let me know. Can you tell me what about option D? Option D is union minus team. That is phi. Okay, means all the players minus team. So basically, all the players have been chosen in team. Yes or no? Okay, because you are doing defender, union forward, okay, minus team. That is phi. That is phi. What that means? It means every defender has been selected in the team, every forward has been selected in the team. Okay, this is your option D. This is a option D. Okay, what option D is saying? Option D. Option D says that every defender is in team and every forward is in team. Yes or no? I can say every defender is in team and every forward is in team. This is what option D is saying. So that's it. Finally, your answer is option C. Okay. If you want to check every person who is in team, that is either defender or forward, then for that answer will be option C. So this is the analysis of all the options. Please tell me, did you understand the complete analysis of this question? Did you understand? Let me know. Remember, this question is based on this concept. Okay, if you want to make sure that every element of R is in S, then R minus S should be equal to phi. Okay, very simple. R minus S is phi if and only if R is subset of S. Similarly, R is subset of S if and only if R minus S is phi. So remember, this gate exam question is based on this concept. Please tell me, did you understand this? Let me know. Let's move on now. Let's solve this gate 2000 question. Given the relations employee, department, which of the following queries cannot be expressed using the basic relational algebra operations? These are the basic relational algebra operations you can see. So you can see select, project, cross product, join, union, intersection, and difference. So you can see these are the operations. Using these operations, which query cannot be expressed, which of the following query cannot be expressed? Okay, what will be the answer? Very simple. The answer will be option C, the sum of all employees' salary. Okay, this you cannot express because we cannot do summation in the relational algebra. Yes or no? In the basic relational algebra, we cannot do aggregation. We cannot find summation, average, minimum, maximum. Okay, yes or no? Is this clear? Please tell me. So, very simple. We cannot do aggregation. Okay, aggregate operators, those are not there in the basic relational algebra. Okay, very simple point. So finally, here the answer will be option C. Remember, you can do this. Department address of every employee. Okay, for every employee, what is the department address that you can easily find? Okay, yes or no? So you can combine by joining these two tables, we can find the department address of every employee. Okay, if you want option A, then you can join these two tables and you can find for every employee, here is the department number, and here is the address of the department. So very simple. For option A, you can join these two tables and you can find. Okay, just do the natural join. That is your answer. Yes or no? For option A, just do the natural join of employee. Just do the natural join of employee and department table. Just do this. Okay, do this natural join. That's it. This is your answer. Next, you can see option B, employees whose name is in he is the same as their department. That is also very simple. Employees whose name is same as department name. Again, what you will do? Again, what you will do? You will do the natural join, and then you will select where employee name is same as department name. Okay, yes or no? What you will do? First, you will do the natural join. First, you will do natural join. Then you will select tuples where employee name is the same as department name. Where employee name, E name is equal to same as D name. So this is the answer for option B. What about option D? Let's see. What is option D? All employees of a given department, let's assume department D0. Okay, because the question is saying given department. So let's assume department D0. Now we want all the employees of department D0. Then what that will be? Tell me. Very simple. From the employee table, you can select where department number is D0. Yes or no? That's it. That's it. This is your answer for option D. So you can easily see that option A, B, D, for these options, option A, B, D, these options we have relation algebra query. Basic relation algebra query we can easily write. But for option C, we cannot write relation algebra expression. The basic relation algebra expression we cannot write. Is this clear? Let me know. Let me tell you one thing. In the relational algebra, you can see in this, there are six basic operations. Actually, in the relational algebra, there are six basic operations, that is select, project, Cartesian product, set difference, union, rename. These are the six basic operations. Okay, you can see sigma, pi, cross, minus, union, and rename row. So you can see these are the six basic operations. Now from these six basic operations, you can derive some operations, like these are the additional derived operations. Remember, these are the derived operations. You can derive them from the basic operations. These are the derived operations. Okay, you can see intersection, natural join, theta join, and division. These are the derived operations. These operations you can derive from the basic operations. From these basic operations, we can derive these operations. Okay, but let me tell you one thing. There are some operations which are not part of basic relation algebra. You can see these are the extended operators of relation algebra. Means what it means? It simply means these are not part of basic relational algebra. These are not part of basic relational algebra. What it means? It means these operations we cannot write using the basic operators of relational algebra. Means these cannot be implemented. These cannot be implemented using basic relational algebra operations. Okay, so remember, these are extended operations. For example, duplicate elimination, okay, aggregation operator, grouping, Okay, you can see the sorting if you want to do sorting, and also outer join. All these are extended operators. Okay, is this clear? You can see outer join, sorting, grouping, aggregation. Okay, in the aggregation you have summation, average, these type of things. So remember, all of them, these are extended operators, means these are not part of basic relational algebra. I can say these cannot be implemented using the basic relational algebra operation. Okay, very simple point. Okay, so this outer join, sorting, grouping, aggregation. Okay, remember aggregation means summation comma average. So like this. Now you can easily see for this question, which cannot be expressed using basic relational algebra expression operation, that will be the answer will be the summation of all the employee salary. Okay, what about this? If the option E, let me give you some more options. If the option E is outer join, tell me about this. If the option F, that is division, what about this? Tell me. The next option is, let's assume, natural join. Okay, like this. And let's assume the next operation, that is intersection. So now you tell me. Now you can see that this outer join, this also we cannot express. Okay, so now the answer will be option C comma E. Okay, option C comma E. That's it. Remember, these can be expressed. These can be expressed using basic relational algebra. Okay, so that's it. So here the answer will be option C comma E. Now let's move on. Let's solve this GATE 2012 question. Suppose RAB, R1 AB, R2 CD. What this underline means, let me know. What this underline means. You can see RAB, A is underline. Underline means primary key. Okay, remember, underline, underline means primary key. Means primary key. So this table R1 has primary key A. This table R2 has primary key C. These are the two relation schema. R1, R2, these are the instance you can see. Okay, so B is foreign key that refers to C in R2. If data in R1, R2 satisfy referential integrity, then which of the following is always true? See, the question is very simple. The question is saying that you have table R1 and table R2. In the table R1, you have A comma B, where A is the primary key. In the table R2, you have B comma C, where, sorry, C comma D. Okay, in the table R2, you have C comma D, where C is the primary key. Now the question is saying that this B is foreign key, referring to C. You can easily see B is foreign key that refers to C. Okay, B is foreign key that refers to C in R2. So you can see this B, this is referring to C in R2. Now the question is saying that we have R1, R2, which are instances. Okay, so there is instance R1 of capital R1, and there is instance R2 of capital R2. So for this table, this is the instance, and for this table, this is the instance. Now, the question is saying the data in R1, R2 satisfies referential integrity. What that means? Can anyone tell me? The data here satisfies referential integrity. The data here, they satisfy referential integrity. What that means? That means every value here should be here also. Okay, do you agree with me? Very simple point, that every value here, for example, if you have b1 here, that must be here. Okay, that must be here. Okay, this b1 must be here. If you have value b2 here, that must be here. Okay, that must be here. Can you have this situation that you have b3 here and there is no b3 here? Can you have this situation? You have b3 here and there is no b3 here. Can you have this situation? No, we cannot have this situation, because this b, this is a foreign key referring to this attribute c. So referential integrity simply means that every value here, every value in this column b, that should be here. Remember, there can be extra. For example, you can have b3, b4. These things can be extra. Okay, in this column C, you can have extra. But every value that you have here, that should also be here. Very simple point. What this means, remember, I can say that values that are in B, values that are in B, okay, they must be subset of values that are in C. This is referential integrity. Yes or no? This is a referential integrity. Values that are in B, they must be subset of values that are in C. This is referential integrity. That every value in this column that should also be present here. But remember, here you can have extra something. So tell me what should be always true? Can I say what should be always true? Let me know. So very simple. I can easily say that this B minus C must be phi. Yes or no? Very simple point. Remember values. Okay, I can say this B is a subset of C. I can simply, in simple words, I can say this B of R1 must be subset of C of R2. This is referential integrity. This is a referential integrity. Now you can easily see, if you want this to be subset of this, then what should happen? This minus this should be equal to phi. That you already know. If you remember, see, this is the result. If you have, for example, R minus S, that is phi if and only if R is subset of S. Okay, very simple point. If you want to say that R is subset of S, if you want to say R is subset of S, then what should happen? Then R minus S should be equal to phi. Okay, these are simple results. Now the same thing you can apply here. So here you can see, if this is subset of this, then what should happen? I can easily say that this B of R1 minus this C of R2, this whole thing must be phi. This whole thing must be phi. Is this clear? Please tell me. So this is the simple answer. So this should always be true. So here you can see the answer will be B of R1 minus C of R2 should be phi. Answer will be option C. Answer will be option A. Option A will be the answer. Okay. So very simple point. Now let's move on. Let's solve this TIFR question, TIFR 2013 question, a very simple question. In a relational database, there are three relations. Customer, in this table, we only have customer names, only one attribute, customer names. Shops, here you have shop names. Okay, all the names of the shops. Next, buys, which customer is buying from which shop. Very simple. These are the three simple tables, very simple tables. Here only one attribute, here two attributes. Okay, which of the following relational algebra expression returns the names of shops that have no customers at all? Okay, which shops have no customer at all? See, look at this table, shops. Okay, there is this table, shops. This has only, see, notice this has only S name, means this has all the shops names. Yes or no? This has all the shops names. For example, maybe shop S1, shop S2, shop S3. So this has all the shops names. Now you can see there is another table that is buys. There is another table that is buys. Okay, buys. Here you have which customer is buying from which shop. Okay, so there is this table buys B. Here we have which customer is buying from which shop. C name, S name. Okay, so now you tell me, I want those shops which does not have any customer at all. I want to return those shops which have no customer at all. Which have no customer at all. Means, tell me, if some shop has no customer at all, can that shop be here? Can that shop be here? If some shop does not have any customer at all, for example, let's assume this S2 has no customer at all. Let's assume this has no customer at all. Then can you have S2 in this table, in this buy table? In this buy table, can you have S2? You cannot have S2. Yes or no? So very simple point. What I'm saying that what you do, you find all the S names from this table, okay? And then from this table, you remove this. Then the names that you will get, those will be shops where there is no customer at all. Are you getting my point? If this S2 has no customer at all, then S2 will not be here. Okay, yes or no? In this table, you will not have S2. I can say here you will not have S2. There will be no S2. Okay, so finally I am saying that if from all the shops, okay, means from this table, remember from the as table, if I remove, if I remove as names of table B, means this attribute I project. Okay, this as name, basically these shops I find. Okay, now from all the shops, if I remove these shops, then what I will get? I will get shops which have no customer at all. Yes or no? This will give me shops with no customer. Is this clear? Please tell me. And what about this? What about what this will give me? Tell me what this will give me if I just project as name from buys table. If I project as name from the buys table, what this will give me? Let me know. What this will give me? This query. This query will give me shops with at least one customer. Yes or no? Shops with at least one customer. With at least one customer. Okay. Is this clear? So this is your shops with at least one customer. Now from all the shops, if you remove these shops, then you will get shops with no customer at all. So finally answer will be S minus pi B. Okay, so you can see answer will be S minus pi B. Answer will be option C. Is this clear? Please tell me. What about option A? What option A is giving you? Let me know one by one. Answer is option B. What option A is giving you? What option A is giving? You can see this is giving you shops with at least one customer. Yes or no? Shops with at least one customer. With at least one customer. This is your option A. What is option B? What is option B? Tell me, tell me, tell me. What is option B? That is invalid. Option B is invalid. Option B, that is invalid. Do you agree? Why this is invalid? Because they are not union compatible. See, these two tables, they are not compatible. They are not type compatible. They are not type compatible. They are not union compatible. So because they are not type compatible, so you can see option B, that is invalid query. Okay, is this clear? What about option D? What option D is giving you? Tell me. Look at option D. Let me write it here. S minus pi as name. Let's look at option D. S minus pi as name. And what you are doing C cross S minus B. Okay, so tell me what this query is giving us. Very simple. You tell me one by one. What this C cross S? This is all the customer comma shops combination. See, this is all the customers. This is all the shops. Here you have all the customers. Here you have all the shops. You can see in C you have all the customers. In S you have all the shops. So what will be C cross S? This is all customer comma. This is all customer shop combinations. Okay, yes or no? These are all, remember, these are all the combinations. These are all combinations of customer comma shop. And minus, these are actual customer comma shop combinations. Yes or no? This is the buys table. Remember, this is the buys table. Which customer is buying from which shop? Correct? Yes or no? Which customer is buying from which shop? So you can see these are the actual customer shop combinations. Now you tell me, from all the combinations, if you remove the actual combinations, what you will get? Let me know. From all the combinations, if you remove the actual combinations, what you will get? You will get the combinations where customer is not buying from the shop. Yes or no? Okay, this will give you what? This will give you those shops, those combination. This will give you customer this will give you like this. Okay, C1 S1. This type of combinations. C1 S1 type of combinations. C1 S1 type of combinations where C1 doesn't buy from S1. Do you agree? Where C1 doesn't buy from S1. Is this clear? Let me know. Remember, C cross S. Here you have all the customers. Here you have all the shops. So if you do their cross product, you will get all customer shop combinations. And this table, this buys table, this has all the actual combinations. Means actually which customer is buying from which shop. So if you remove from all the combinations, if you remove the actual combination, you will get this type of combination. C1 S1, this type of combination you will get where C1 is not buying from S1. This customer is not buying from this shop. Now, if you project this pie, then what you will get? If you project as names, what you are going to get? Now, if you project this S1, basically this S1 you are projecting. So you will get those shop where at least one customer is not buying. I can say now you can see these are the those shops. These are those shop names, okay, where where not all are buying. Yes or no? Where not all customers are buying. Are you getting my point? Where not all customers are buying from. Okay, is this clear? So very simple. You will get because you are projecting the S name, shop name. So remember, this S1 will come in the output. This S1 will come in the output, and you can see from this S1, C1 is not buying. From this shop S1, C1 is not buying. So I can say you will get those shop names where not all customers are buying. Where not all customers are buying. Is this clear? Where not all customers are buying from. Now you tell me, from all the shop, if you remove these shop, final result will be what? Tell me. So remember here you have those shop names from which not all customers are buying. Not all customers are buying. Okay. Buying from. So now you tell me, from all the shops, and these are all shop names. These are all shop names. Now you tell me, from all shop names, if I remove this, then what I will get? Please tell me. If I remove this, then finally what I'm getting? Tell me, finally what I'm getting? From all the shops, if I remove these shops where not all customers are buying, then I will get those shops where all customers are buying. Yes or no? I will get those shops where all customers are buying from. Where all customers are buying from. Customers are buying from. Is this clear? Let me know. So option D is giving us those shops where all customers are buying from. That shop where every customer is buying from, like DMart. Okay. So those shop where every customer is buying from, where all customers are buying from. So this is option D. But our answer is not option D because we want those shop where there is no customer. So our answer for this question, for this TIFR question, our answer is very simple. Answer is option C. But I gave you the analysis of option D. So what is option D? I have given you the analysis of option D. Option D is basically shops where all customers are buying from. Shops where all customers are buying from. Is this clear? So this is the complete analysis of this question. Actually, this is a very easy question, and the answer is option C. Very quickly, you can see the answer is option C. But I've given you the analysis of all the options. I've given you the analysis of option D also. What is option D? That is shops where all customers are buying from. Okay. Now let's move on. Now let's solve this TIFR 2010 question. Again, you can see the same table, customer table, shop table, and buys table. Now the relational algebra expression, what this will give you, this expression is the same as this expression. We have done the analysis. Yes or no? Option D. Did you notice? See, this is TIFR 2013 question 13, and you can see this is TIFR 2010 question. Okay, but you can see that option D, this is your option D. Sorry, actually, just a small difference. There is a small difference. These are the customers which are buying from all the shops. Okay, there is a small difference. This is very similar to option D of option D of TIFR 2013 question. Yes or no? This is similar to option D of TIFR 2013 question. Okay, actually, we will do the analysis of this also. But what this will give you? This will give you customers which are buying from all the shops. This will give you customer who buy from all shops. So the answer will be option C. Okay, let's do the analysis here. So this is the query. You can see there is customer table. There is customer table C where you have customer names only. That's it. Okay, there is shop table S where you have shop names. So here you have all the customers, here you have all the shops, and there is another table that is buys. That is buys table. This table is telling you which customer is buying from which shop. Okay, which customer is buying from which shop. So these are the three tables. Now look at the query that is given to us. The query is this, that from C you are removing pi customer name. Okay, customer name, and here you can see C cross S minus B. So this is the query. Now let's look at it one by one. Okay, first you tell me about these, what this query will give you. See, what is this? C cross S. What is this? C, this has all the customers, this has all the shops. So what is C cross S? Tell me. Here you have all the customers, here you have all the shops. So what is C cross S? Tell me. This is a this is all customer comma shop combination. Yes or no? This is all customer comma shop combination. These are all the combinations of customer comma shop. Okay, because here you have all the customer, here you have all the shops. If you do the cross product, you will get all customer shop combinations you will get. And here what you have in this table B, you have actual customer comma shop combination. Here you have actual customer comma shop combination. Actual customer shop combinations you have. Yes or no? Okay, because in this table you have the actual combinations, which customer is buying from which shop, which customer is buying from which shop. Okay, so these are the actual customer comma shop combinations. Very simple. Now you tell me, from all combinations, if you remove the actual combinations, what you will get? From all combinations, if you remove actual combinations, what you will get? Let me know. Here, from all customer shop combinations, if you remove the actual combinations, because this will give you those customer shop combination where customer is buying from the shop. Okay, in this table you have which customer is buying from which shop. So if you remove from all the customer shop combination, if you remove the actual combination, then you will get this type of combination. You will get C, C1 S1. This type of combinations you will get. This type of combinations we will get. Okay, where where C1 is not buying from S1, where C1 does not buy from S1, does not buy from S1. Okay, does not buy from S1. Then finally we are projecting the customer names. So which customer names we are getting? Now this C1 will go to the output, yes or no? Because we are projecting customer names. So this C1 will go to the output. So it means those customers which are not buying from all shops, yes or no? Because you can see C1 is not buying from S1. This customer C1, this does not buy from S1. Finally, this C1 is going to the output. Okay. Then basically those customers we are getting which do not buy from all the shops, those customers who do not buy, who do not buy from all shops. Okay, who do not buy from all shops. Yes or no? They can buy from some shop, but they do not buy from all the shop. Okay, it is possible they can buy from, let's assume, Pantaloon, they can buy from Judio. Okay, but they do not buy from all. For example, they do not buy from West Side. Okay, they do not buy from, I can say, Starbucks. Okay, so remember those customers who do not buy from all shops. Okay, this is what we are getting. So finally, remember, here we have those customers. Here we have those customers which who do not buy from all shops. Customers. Here you have those customers who do not buy from all shops. They can buy from some shop, but they do not buy from all shop. Means they do not buy from at least one shop, I can say. These are the customers who do not buy from at least one shop. There is at least one shop from which they do not buy. So very simple, these are the customers who do not buy from all shops. Now you tell me, these are all the customers. These are all customers, because here you have all the customer names. This is your C. So all the customers. Now you tell me, from all customers, if I remove the customers who do not buy from all shops, what I will get? All customers minus those customers who do not buy from all shops. What I will get? I will get customers who are buying from every shop. Customers who buy from every shop. Who buy from every shop. Okay, yes or no? We will get customers who buy from every shop. This is your final answer. That's it. So you can see, for this gate exam, for this TIFR exam question, the answer will be option C. Customers who buy from all shops. This is your answer. Is this clear? Please tell me. Let me know. So this is TIFR 2010 question. We have done it. And this is TIFR 2013 question. We have done it. This question, this TIFR 2013 question and this TIFR 2010 question, they are similar. They are similar, you can see. Okay, let's move on. Let's solve this GATE 2022 question. This another question based on division operation. This is a very simple question. See, consider the following three relations in a relational database. These are the three relations: employee relation, brand relation, own relation. Let me tell you, this question is MSQ question. In 2022, this was MSQ question. Multiple options can be correct. Okay. What the question is saying, here you have employee table where you have employee ID and the name. Here brand table, brand ID and brand name. And this is the own. Okay. Which employee owns which brand? Okay. Very simple. Which of the following relational algebra expression returns the set of set of employee IDs who own all the brands? Okay, who own all the brands? Those employees who own all the brands. Tell me one thing. When you see all, this keyword, when you see, then what comes to your mind? Those those EIDs. We want those employees who own all the brands. Who own all the brands. When you see this word all, what comes to your mind? Division operation should come to your mind. When you see this word all, then division operation comes to your mind. Okay, division operation must come to your mind. So very simple point. Now let's do this. What we want employee ID. We want employee ID who own all the brands. So here you will get employee ID. Which tables we need? Tell me. Just tell me, for this query, which tables we need? Let me know. Which tables we need for this query? We want employee ID that you can get in this table. Who own? Employee ID who own. Okay, so this information you will get from the own table. This information you will get from own table. Okay, yes or no? This information, remember, this information you will get from the own table. And this all the brands, this information you will get from where? All the brands, all the brands, all the brands. This information you will get from where? All brands you will get from the brand table. Do you agree? Let me know. See, very simple point here. Set of employee IDs who own. Employee ID who own. This is from the on table. Okay, this information you can find in the on table. Okay, which employee ID is owning which brand, which employee is owns which brand. All the brands, this information you can find from the brand table. Now, very simple. So finally, two tables you need. One is on table, another is brand table. Okay, these two tables you need. So let's see. So now you have on table. In the on table, you have EID and you have BID, brand ID, and there is brand table. Here you have brand ID and what is the brand name? Okay, what is the brand name? Now, what we want? We want employee IDs who own every brand. Yes or no? I want employee IDs who own all brands. Okay, who own all brands. So very simple, all brands. Now, for this, you will apply the division operation. Okay, all brands, that simply means division operation. So here you will apply the division operation, very simple, division operation. Now, for the division operation, I want employee IDs. Ultimately, I want employee IDs. So on the left, I will put the on table. Yes or no? On the left, because ultimately I want employee IDs. Ultimately, I want employee IDs. So on the left, I will put employee this on table EID, comma BID. Okay. Here on the right, what I will put? I will just project BID. Tell me, if I put this as it is, then this will be invalid. Do you agree with me? See, if I put this brand table as it is, if this brand table, if I put as it is, now you can see that this division operation, this complete query will be illegal, invalid query. This query will be invalid. This is invalid division query. Yes or no? Because in the division query, what should happen? This must be superset of this. This LHS must be superset of RHS. You know that R divide by, okay, whenever you have this type of situation, RX divide by SY. Okay, this is valid. When this will be valid? This will be valid if and only if X is a superset of Y. X must be superset of Y. So is this clear? So remember what I will do? I will only find the BIDs. Okay. I will only find the BIDs because I want employee who own all the brands. So here I can find the BIDs. Just project the BIDs. Now this query is correct. Is this clear? Okay, that's it. That's it. What this query will do? What this query will do? This query will give you ultimately output will be what? Okay, EID BID divided by BID. EID BID divided by BID. The output will be what? The output will have only EID. Yes or no? Remember, in the output, what you will get? In the output, you will only get EIDs. This is the output. You will get EIDs. And remember, these will be those EIDs who own all brands. These will be those EIDs who own who own every brand. Okay, we will get those employees who own every brand. Okay, those employees who own every brand. So very simple, yes or no? So that's it. So your final answer, let me tell you, your final answer is this. Now look at option A. Actually, in this option A, can you notice that this again you are projecting EID? That is actually unnecessary. Yes or no? That is redundant. Are you getting my point? That is actually redundant. Okay, but that is correct. There is no problem. Yes or no? Option A is correct. But you don't even have to, you do not see, you do not need this. You don't need this. Now also it is correct. Option A is correct. Now also option A is correct. Yes or no? EID BID divided by BID. The result will have EID. The result will automatically have EID. So actually in this option A, this is redundant, but this is fine. Yes or no? So option A is correct. Are you getting my point? Let me know. Is this point clear? What I'm saying? Basically, what you are doing in option A, what you are doing, notice, you are doing like this. See, already your result has EID. Already your result has EID. Now you are again projecting EID. So that is redundant. That is a redundant. Is this clear? So even if you remove this, then also option A is correct. But this is also fine. Okay. Already you have EID, and if you project EID, that will be same as your EID. Yes or no? So remember, this is actually redundant, but this is correct. But this is correct. Okay, so I can say option A is correct. Is this clear? Now let's see the remaining options. What about the remaining options? Let's look at them. First, let's look at the easy options. What are the easy options? Let's look at option C. Tell me, is this option C correct? Let me know. Look at option C and tell me, is this option C correct? What is the difference between option C and option A? Anyone? What is the difference between option C and option A? See, in option A, you have this brand. Okay, let's do the analysis of option C. Option C analysis. So tell me, in option C, did you notice that? In option A, we are dividing by all brand. Remember, we are dividing by all the brands. But in option C, we are choosing the brand from the on table. So we are not dividing from all the brands. Yes or no? Yes or no? So actually, what this option C will give you, this will give you, okay, remember, this is very simple. Notice what is option C. Option C is like this. That option C is like this. Let me tell you. Option C is that you are from the on table. Okay, from this on table. In this on, what you have? You have EID, BID. You have EID, BID divided by you are selecting BID from the on table. Okay, means you are not selecting all the brands. Do you agree with me? You are not selecting all the brands. You are not selecting all the brands. You are not choosing all the brands. You are choosing brands, not all brands. These are the brands owned by at least one employee. These are the brands owned by at least one employee. Do you agree with me? At least one employee. You are not selecting all brands. You are selecting brands which are owned by at least one employee, because you are selecting the BID from the on table. From this table, you are selecting the BID. Means you are selecting the brands which are owned by at least one employee. Okay, so now if you do this, then option C, what this will give you? Option C will give you those employees who own every brand which is owned by at least one employee. Okay, yes or no? Basically, those employees, those EIDs who own every brand, who own, okay, who own every brand which is owned by at least one employee. Every brand which is owned by at least one employee. Okay, so this is the answer. So let me tell you a concrete example. For example, let's assume in the on table, let's assume you have BID and EID. Yes or no? You have EID, BID. And let's assume this is the actual brand. These are the all the brands. In brands table, you have BID, B name. Okay, now notice. Let's assume that here this employee is owning the brand. Okay, some brand. Let's assume even owns B1. Okay, and let's assume E2 owns B2. And let's assume E1 owns B2. So like this. Okay, is this clear? Now you can see. But let's assume in the brand table you have B1 also. Okay, you have B2 also, but you have B3, B4 also. Okay, yes or no? You have B3, B4 also. Are you getting my point? So let's assume this is the situation. Now in this situation, what option C will give you? Option C outputs. What will be the output of option C? Tell me. Option C will give you those employee IDs who own every brand which is owned by at least one employee. So basically, option C will give you the output even. Yes or no? Outputs E1. Do you agree with me? But but actually you can see they do not own all brand. The question is saying who owns all brand? Yes or no? Notice the question is saying EIDs who own all the brands. Who own all the brands. So you can see that option C will give you even, but 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 query in but query asked in question outputs outputs none of them. Okay. So I hope you understood that option C is not correct. Okay. So option C is wrong. We have found it. Option C, option C is wrong. What about option D? Can you tell me? Let me know about option D. Let's see the option D analysis. Please tell me what is the analysis of option D? In option D, what we are doing? Notice what we are doing here. We are finding EID from the on table and BID from the on table, and we are doing their cross product. Means this EID we find separately, this BID we find separately, then we are doing their cross product. Then we are dividing by all the brands. Okay, so will it give me the correct output? Let me know. Will it give me the correct output? What do you think? Will it give me this option D? Will it give me the correct output? No, option D will not give you the correct output. Okay, for option D, let me give you a situation. Consider this situation for option D. This interesting situation, let me give you. Let's assume that in the on table, you have EID, BID, right? You have EID, BID. Let's assume, and here you have the brand table. Here you have BID and B name. Okay, BID and B name. Now you notice. Let's assume that this B1, okay, this employee E1, let's assume this owns B1. Employee E2 owns B2. Okay, and these are the brands B1, B2. Okay, only two brands are there, B1, B2. Now you tell me actual answer should be what? Let me know the actual answer should be what? Just tell me the actual answer must be what? What should be the actual answer? These are all the brands. B1, B2, these are all the brands. And you can see E1 owns B1, E2 owns B2. Is there any employee which owns all the brands? Is there any employee who owns all the brands? No. So actual answer is no employee. Yes or no? Actual answer is none of them. None of them will come basically empty. Actual answer is basically empty. But now you notice what option D will give you. But now you notice what option D will give you. Please notice. See, in the option D, what we are doing? First, we are finding EID from the on table. So this EID will give me what? From the on table. From this table, if I find EID, what I will get? I will get even E2. So this will give me even E2. Next, what this will give me? From the on table, if I select, if I project BID, from the on table, if I project BID, what I will get? I will get B1, B2. Now what I will do? I will do their cross product. Okay, if I do their cross product, then what I will get? I will get E1, B1, E1, B2, E2, B1, E2, B2. Yes or no? Now in this cross product, if I divide by all brands, if I divide by B1, B2, then what I will get? In this cross product, if I divide by B1, B2, what answer I will get? Tell me. This cross product, I divide by B1, B2, what answer I will get? Remember, in this, what you will have? Here, what you will have? Here, you will have E1, B1, E1, B2, E2, B1, E2, B2. So, if you divide by B1, B2, you will get even E2. Yes or no? Very simple. So option D will give you answer E1, E2. This will be option D answer. This is option D answer. Actual answer is empty table. So option D is wrong. Yes or no? So option D is wrong. Is this understood? Please tell me. So option D is also wrong. What about option B? So we have seen option C, comma D, they are wrong. Okay, they are wrong. We have seen that. Option A is correct. We have seen that. Option A is correct. What about option B? Let me know. What about option B? Option B is also correct. And if you remember, in our lectures, we have seen that option B is basically how to write the division operation in terms of basic operations. Yes or no? How to write division operation in terms of basic operations. This is what option B is. And we have already seen this in our lectures. I will put the link in the description. So if you have any difficulty in option B, in understanding option B, then I will put the link in the description. You can check it out. We have already seen in our lectures very clearly, in a very easy way. I told you how to write division operation in terms of basic operations, and basically option B is that. If you remember, do you remember? Are you getting the idea? This is the ideal minus actual. If you remember, in our lectures, we have already seen this. This is ideal. Basically, EID cross product with BID from the brand table. See, EID cross product with BID of the brand table. This is the ideal pairs. These are ideal pairs minus actual pairs. Ideal pairs minus actual pairs. Minus actual pairs. Ideal pairs minus actual pairs. This will give you what? Okay, then you are projecting EID. These are disqualified. Yes or no? These are disqualified pairs. Do you agree with me? So remember, you are basically getting disqualified EIDs. Okay. Now from all EIDs, if I remove disqualified EIDs, all EIDs minus disqualified EIDs, what I will get? All EIDs minus disqualified EIDs, that will give me what? That will give me qualified EIDs. That will give me EIDs who own every brand. Okay, is this clear? So very simple. So option B is also correct, because remember, what is option B? Option B is basically the division operation in terms of basic operations. I told you we can write division operation in terms of basic operations, and option B is that. Okay, so remember option B. Actually, option B is very simple. Option B is writing division in terms of basic operations. Writing division operation in terms of basic relational algebra operations. Okay. And for that, I told you how to write this. Let me tell you, very simple. If you have R A comma B divided by S B, you know the result. You know the result. The result will be only A. Okay. In the output, you will have only A. Yes or no? The result will be only A. Now, so what is the query? Very simple. I told you that how, what is the idea? The idea is very simple. Okay. All R dot A values, all R dot A values minus all R dot A values minus disqualified A values, minus disqualified A values. Okay. So what are disqualified A values? These are ideal minus actual. Okay. These are ideal pairs minus actual pairs, minus actual pairs. If you remember, so remember all R dot A values, that is very simple. If I want all R dot A values, that is very simple. Pi A from R minus disqualified. Who are disqualified? Who are disqualified? Very simple. Ideal minus actual. What are ideal? See, ideally, these A values, they should pair with every S value. these a value, they should pair with every s value. So ideally, these a values, okay, remember these a values means pi ar. These a values, they should pair with every s value, means cross product with s. Okay, cross product with s. So this is ideal. Minus, what are the actual pairs? The actual pairs are this r itself is actual pairs. Yes or no? This R is actual pairs. Then what you do? Then you select A values. These are the disqualified A values because I want disqualified A values. So very simple. All A values minus disqualified A values. This is your this is your division query. This is the division query. So very simple note. What is division query? If you have RAB divided by SB, you know the result, you know the output. The output will have only A. Okay, and the query is very simple. So the query is like this: pi ar, all the a values minus disqualified a values. What are the disqualified a values? Those are ideal means this cross s. These are ideal, minus actual is r. So this is your answer. Okay, that's it. So here you can see that option B, that is basically division operation in terms of basic relational algebra operations. So for this question, for this 2022 question, the answer will be option A comma B. These will be correct. Option C comma D are wrong. I have already given you the example. For option C, for option D, I've given you counter example. Why option C, why option D are wrong? I have given you the counter example. Okay. So very simple. So this is your GATE 2022 question. Please tell me, did you understand? Let me know. So far, every question is clear to everyone. Please tell me. Let me know. Now let's move on. Now let's solve this GATE 2015 question. Select operation in SQL that is equivalent to what? Select operation in SQL. So this question actually needs your knowledge of SQL and relational algebra. So let me tell you, if you did not watch SQL lecture so far, I will put the link in the description. You can watch it, or you can solve this question after watching SQL lectures. Okay. So once you watch SQL lectures, then you can solve this question very easily. Okay. If you did not watch SQL lecture so far, then don't worry. Once you watch the SQL lecture, then this question is very basic, very basic question. So the question is saying select keyword in SQL that is equivalent to what? In SQL, we have select keyword that is equivalent to projection of relational algebra. Yes or no? But you know that select this can have duplicate tuples. Yes or no? It can have duplicate tuples. Okay, but in relational algebra, we don't have duplicate tuples. So the answer will be option D. Okay, you can see that select operation of SQL that is similar to projection operation of relational algebra, except that select in SQL retains duplicates. Okay, so the answer will be option D. Is this clear? Let me know. Because remember, this select operation in SQL, this does not eliminate duplicates. Yes or no? This does not remove duplicates, duplicate tuples. This does not remove duplicate tuples. Yes or no? Okay. But you can see relational algebra that removes duplicate tuples. Yes or no? There are no duplicate tuples in relational algebra. In the relational algebra, there are no duplicate tuples. We never have duplicate tuples. Okay. So the answer will be option D. Is this clear? Very simple. So let me tell you the comparison in relational algebra and in SQL. In SQL and in relational algebra, which operations are equivalent? For example, in relational algebra, we have something called pi, that is projection. Yes or no? Pi means projection. So for projection in SQL, what we use? Which keyword we use for projection? We use select. Okay, we use select. Yes or no? This select keyword we use for projection. But let me tell you one thing. If you want to make them exactly equal, then what you need? See, here there is no duplicate. This does not remove duplicate. If you want to make them exactly equal, then you can use distinct keyword in SQL. Distinct. Now they are exactly same. Yes or no? Now they will be same. Select distinct. Now this will remove the duplicate tuples. Yes or no? Select distinct. This will remove the duplicate tuples. This will remove duplicate tuples. Now they are same. Similarly, you tell me the selection in relational algebra. We have selection operation. This is the selection operation. We select the tuples. We filter the tuples. In SQL, what we have? Which keyword we use in SQL to filter the tuples? We use where keyword. Okay. Similarly, in SQL, in relational algebra, we have cross product. We have cross product R cross S cross T. So tell me, in SQL, which keyword we use? We use the from keyword. Yes or no? From R comma S comma T. So like this. I hope this point is clear. So these are the differences between SQL and relational algebra. Now let's move on. Now let's solve this GATE 2003 question. Again, this question needs the knowledge of SQL. So if you did not watch SQL lecture so far, do not worry about it. After completing SQL, you can watch this solution. But if you have already watched SQL lectures, then you can solve this question easily. I will put SQL lectures link, I will put in the description. So you can check the description. In the description, SQL summary lectures, complete SQL summary lectures are available. You can watch them and you can solve this question. So let's solve it. This is GATE 2003 question. Consider the following SQL query. Select distinct. So there will be no duplicates. Yes or no? There will be no duplicate tuples in the output. Select distinct. There will be no duplicate tuples in the output. Okay, so let me tell you one by one. This select means projection. This is similar to projection. Do you agree? This is similar to projection. Projection means pi. Okay, so this is similar to projection. And this distinct means there are no duplicate tuples. This distinct means there are no duplicate tuples. In the output, there are no duplicate tuples. There are no duplicate tuples in the output. Okay, in output. There are no duplicate tuples in output. Simple. Okay. So select means projection and distinct means no duplicate tuples in the output. These are the attributes. Okay. So what is the meaning of the first line? The complete first line, what that means? Select distinct A1 to AN. What this complete line means? This complete line, what that means? Select distinct A1 to AN. That simply means you are projecting A1 to AN. Okay, yes or no? Because in SQL, this select keyword, this is similar to projection of relational algebra. Okay, you can see here in relational algebra we have this projection pi. Okay, for this in SQL we have select distinct. Okay, this distinct, this will remove all the duplicates from the output, and this select, this keyword we use for projection. So very simple. So here you can see that. Now what about this one? From R1 to RM. This is similar to your cross product. Yes or no? This is similar to cross product. You are doing cross product. Okay, I told you here you can see, if you want to do cross product R cross S cross T, then in SQL you have this keyword from RST. That means R cross S cross T. These two things are same. This and this. These two things are same. Okay, so very simple. Now what about this where P? This is your tuple selection condition. This is similar to sigma p, tuple selection condition. I told you that in relational algebra we have this selection. Okay, this tuple selection condition we have. In SQL we have where keyword. They are same. In SQL you have where keyword. So this p where p. Okay, these things are same. So here very easily you can see. So finally, what will be the answer? What will be the answer? Remember, I told you, if you remember, I told you what we do first. First, in the conceptual evaluation, first we do this. So first you will do cross product. Okay, remember, first you will do cross product. R1 cross R2 cross RM. This is what you will do first. This is what will happen first. Then second, this will happen. Okay, second, this will happen. Means second sigma P. This will happen. This is a second thing. Okay, this is a second. This is second. Next, After that, what will happen? The third last step will be, this will be third. Okay, third step will be, you are projecting a1 to an. This will be the last step. So this will be your third step. So finally your answer is what? Answer is option A. Is this clear? Please tell me. Let me know. Is this point clear? Answer is option A. So the answer will be option A. Now let me tell you one more thing. A student is having doubt in select distinct. Okay, so let me tell you this point. When you write select distinct, okay, select distinct, and if you write, for example, A, B, C, these are the attributes, like for example, A1, A2, A3. Then let me tell you one thing. This distinct, we in the conceptual evaluation, this we do at the end. Remember, this distinct, this we execute at the end, executed at the end. This is executed at the very end, at the very end of query evaluation, of query evaluation. So remember what this will do. This distinct, what this will do, this will remove duplicate tuples. This works on duplicate tuples. This does not work on like A1. No, this works on the duplicate tuples. So remember, this removes, this will remove duplicate tuples from the last output, from the final output. Is this clear? So remember, let me tell you one more thing, that select distinct, it is not applying on A1. No, select distinct applies on the entire tuple. Is this clear? Please tell me. Select distinct, it is like this. You can understand like this. Select distinct, when you say select distinct A1, A2, A3, you can think like this. See, what you can think? You can think that first you will select A1, A2, A3. Okay, you can think. Okay, how to think this? Select distinct A1, A2, A3. First you select A1, A2, A3. Is this clear? First you project A1, A2, A3. Okay, this is what you can do. First you project A1, A2, A3. Is this clear? Now, once you have projected this A1, A2, A3, then you remove the duplicates. Now remove duplicates. Now remove duplicate tuples. Now remove duplicate tuples. Is this clear? This is how this distinct will work. Okay, so don't think that this distinct applies on A1. No, 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 no. This distinct does not apply on A1. This applies on the entire tuple. This keyword applies on entire tuple. Okay, yes or no? This keyword, remember, this applies on entire tuple. Applies on entire tuple. Is this clear? So remember, very simple. When you see this, then what you do? First you project A1, A2, A3. Means first you do this. First you do this. A1, A2, A3 you project. Then you remove the duplicate tuples. Anyway, for this question, answer will be option A. Very simple question. Now let's move on. Let's solve this GATE 1997 question. This is another very simple question. Consider the following relational database schema. Three tables are given to us. Now the question is basically saying, what is the relational algebra expression which contains these operators, which is equivalent to SQL query? This SQL query is given to us. Okay, the question is very simple. We want relational algebra expression which is equivalent to this SQL query, which is equivalent to this SQL query. Okay, is this clear? So let's see how to write. Now this is actually very simple question. You already know that when you have select something, okay, select, let's assume attribute A1, A2. Okay, so select actually distinct. Okay, when you have select distinct A1, A2, and and then you have from, you have tables, let's assume R comma S, and you have where some condition P. Okay, now if this is your SQL query, then this is equivalent to what? This is equivalent to, first to do the cross product R cross S. Okay, then what you do, then you select tuples where this condition P is satisfied. Okay, so this is same as tuple selection condition. And then what we do, then we project A1 A2, then we project A1 A2. Okay, is this clear? So very simple. In this question also the same thing you can do. Notice what we are doing. Select E number. So that is same as projecting E number. At the end we will project E number. Yes or no? From employee comma involved. Okay, from, look at this, look at this, from employee comma involved. So what we will do? First we will do their cross product. Yes or no? We want relational algebra expression. So remember, first we will do the cross product of employee comma involved. So first we will do cross product of employee and involved. We will do the cross product of these two. Then we will select where. Where means select. This is same as sigma. And this from is same as cross product. Okay, this from, this is same as cross product. And this where is same as sigma. And this select is same as pi. Okay, so now you can see we are selecting sigma, we are selecting the tuples. Which tuples we are selecting? This condition, this entire condition you can write here. Okay, this entire thing, this entire thing, let's call it P. This entire thing you write here, P. This entire thing you write here, and then you project E number. This is your answer. Is this clear? Please tell me. Let me know. Very simple, right? Okay, so remember, very simple point. Whenever you have this type of query, okay, you have select something. Okay, select, and let's assume E number from R comma S. Okay, where some condition P, then this is same as what? Then this is equivalent to, first to do cross product, then you select tuples where this condition P is satisfied, and then you project E number. So this is the answer. Okay, the same thing you can do here. One thing that I want to tell you, that is, actually in SQL this select distinct, in SQL this select distinct, when you have this distinct, then this is equivalent to this relational algebra expression. Okay, when you have select distinct, now this is equivalent to this expression. Okay, if you remove the distinct, if you remove the distinct, now they are loosely equivalent. They are not exactly equivalent, they are loosely equivalent. Okay, I can say they are actually loosely equivalent, not exactly equivalent. They are, I can say, loosely equivalent. They are not exactly equivalent, they are loosely equivalent. Okay, because this can have duplicates. This can have duplicate tuples. This can have duplicate tuples, and here we don't have any duplicate tuples, and here there are no duplicate tuples. Okay, so you cannot say they are equivalent, you cannot say they are equivalent, you cannot say they are equivalent. Okay, they are loosely equivalent, because the only difference, what is the difference? The only difference, here you can have duplicate tuples, and here there will be no duplicate tuples. Is this point clear to everyone? Let me know. Is this point clear? So remember, again a very simple thing I'm telling you, that this result can have duplicate tuples. Okay, this SQL query, this can have duplicate tuples. This can have duplicate tuples in the output. You can have duplicate tuples in the output. Duplicate tuples in output. You can have duplicate tuples in output here. Is this clear? Let me know. This SQL query can have duplicate tuples in the output. Okay, but relational algebra query can never have duplicate tuples in the output. So actually this question, this is a subjective question. So you can write this line, yes or no. Please notice, this was a subjective question in GATE 1997. So in this paper, in this subjective paper, when you are writing your answer, then what you can do? When you are writing your answer, you can write, you can mention that this SQL query can have duplicate tuples in the output, but this relational algebra query will not have duplicate in the output. Okay, this relational algebra query will not have duplicate tuples in the output. Okay, so this thing you can mention in this subjective question. Okay, So, but actually this question is very good. See, this gate 2003 question is very good because they are giving you distinct. Yes or no? Is this clear? This gate 2003 question, this is a beautiful question. You can see this is objective question. This is your objective question. But if you notice this gate 1997 question, this is your subjective question. Okay, in the older times, okay, in the old days, the gate exam was subjective exam. Okay, so you can write when you are writing your answer subjective in the subjective paper, then you can mention this line, yes or no. But here you can see this gate 2003. This is a very beautiful question. Here you can see there is select distinct. So here the answer will be exactly equivalent. Option A. So this will be exactly equivalent to option A. So this is actually a beautiful question. Okay, let's move on now. Let's solve this question. A table student with schema. This student table is given to you. The schema is roll number, name, hostel marks, and another table hobby. This is another table, okay, where you have roll number, hobby, name. So you can see these two tables are given to us. Now, the following SQL query is executed on the above tables. This SQL query we execute. Also, this relational algebra query we execute. Yes or no? So remember, on these two tables are given to us. On these two tables, we execute this SQL query. We also execute this relational algebra query. Okay, this relational algebra query. Then the question is asking the difference between the number of tuples output by SQL query and the number of tuples output by relational algebra query. So this is a very simple question. How many tuples this SQL query will give you and how many tuples this relational algebra query will give you? We need to find their difference. This is the question. Okay, so on these two tables, let's execute this SQL query first. Then we will execute this relational algebra query. We will find how many tuples this will give you and how many tuples this will give you, and then we will find their difference. Okay, so let's execute this SQL query. This SQL query, let's execute on these two tables, student table and hobby table. Okay, so you can see. Okay, let's see this from. Okay, first you will do this from student natural join hobby. Okay, so first you will do natural join, yes or no? Okay, what you will do? You will do natural join. So student and hobby, you will do natural join. Remember, this student natural join hobby. This is what you will do. So in the natural join, tell me implicitly which equality you will check. Natural join automatically means what? That equality of same attributes. Yes or no? Equality of attributes with the same name. You can see roll number. Okay, you can see this roll number here. So basically you will check the equality of roll number. Yes or no? That roll number must be same as roll number. Student dot roll number should be same as hobby dot roll number. Yes or no? Is this clear? Hobby dot roll number. So this is what you will check in the natural join. Okay, then you can see where marks is greater than equal to 75. Marks should be greater than equal to 75. Tell me which table has marks. Which table has marks column? Yes, only this table has marks column. So marks should be greater than equal to 75. So which tuples are gone? Remember, marks should be marks should be greater than equal to 75. We want those tuples. Where means this will give you tuple. This is your tuple selection operator. This is your tuple selection condition, right? Okay. So remember what we are doing. We want where marks is greater than equal to 75. Okay. So what I can do, this tuple is gone because here marks is not greater than equal to 75. Okay. So this tuple is gone. Another, this tuple is gone where marks is not greater than equal to 75. 75 greater than equal to 75. Yes. Okay. Yes or no? So these two tuples are gone. Okay. Because of this, because we want marks greater than equal to 75. Okay. And what should happen? And what should happen? Roll number between 2000 and 3000. Now you tell me one thing. 2000, 3000, they are inclusive or not? What this between means? What this between means in SQL? What this between means in SQL? In SQL, what this between means? Are these inclusive or not? 2000, will you consider 2000 or not? Are you getting my point? This between, what does it mean? Between 2000, 3000, inclusive or exclusive? Inclusive 2000 3000 or exclusive? So let me tell you, in SQL, this between this keyword, this is inclusive. Okay, so let me tell you this point, that this is inclusive means, okay, let me mention this point here, that in SQL, okay, this keyword, this between keyword, in SQL, this between keyword is inclusive, is inclusive. Okay, this between keyword is inclusive. What it means? When you write between, when you write, for example, when you write a between 2 and 3, a between 2 and 10, okay, then what this means? Then what this means means that a is greater than equal to 2 and less than equal to 10. So remember, this between keyword is inclusive. Is this clear? So very simple, what we want roll number between 2000 and 3000. This is what we want. Okay, and then finally we want hostel. So very simple. Now let's see what we need to do. Remember, equality of roll number. Okay, equality of roll number. And one more thing, that roll number must be between 2000 and 3000. Okay, so tell me which tuples will match. Let's see which tuples will match. What about the first tuple? Remember, roll number should be equal because you are doing natural join. Okay, there is natural join here. You can see there is natural join here. Student and hobby table. You are doing natural join. So the roll number must be same. And roll number must be between 2000 and 3000. Okay, so you can see, is this between 2000 3000? Is this roll number between 2000 3000? No. So this also you can remove. Yes or no? Okay, so these also you can easily remove because they are not between 2000 3000. Okay, yes or no? So you can remove them also. Now finally you tell me how many tuples will be there. So finally this will match with what? 2369, 2369. So okay, so one tuple will be this because of, oh, is there any other 2369? 2369. Is there any other 2369? No. So because of this, one tuple will come. Okay, one tuple is because of 2369. Okay, one tuple because of 2369. Because I can say it's like this, that this tuple will match with this tuple. These two tuples will match. Okay, these two tuples will match. What else? What about this? 2589, 2581. Yes, 2581. Okay, so remember this tuple will match with this tuple. So 2581. One, okay, this another tuple will come. Okay, yes or no? Next, another tuple will come what? 2643. Notice 2643. This 2643, 2643, 2643. So there will be two tuples. 2643, 2643. There will be two tuples because we don't have select distinct. Okay, there is no select distinct. Yes or no? So duplicates will not be removed. We don't have select distinct, so duplicates will not be removed. Do you agree? Duplicates will not be removed here because we don't have select distinct, so duplicates not removed. Duplicates not removed. Okay, so I can say duplicates not removed. Duplicate tuples will not be removed. Okay, so is this clear? So there will be two tuples because of 2643. There will be two tuples. Okay, what about this one? 2872. So because of this, there will be one tuple. 2872. One tuple because of this. Next, what about this one? 2926. 2926. There will be another tuple. 2926. Next will be what? Tell me. Next, you can see 2959. 2959. So there will be another tuple because of this 2959. Okay. And remember, the roll number should be between 2000 3000. Between 2000 3000. So this tuple also will be removed. Okay. You can remove these tuples also because very simple, that roll number should be between 2000 3000. So you can remove these tuples which are more than 3000. Which are more than 3000, you can remove these tuples because they are more than 3000. Yes or no? So finally, tell me, How many tuples in the output? 1, 2, 3, 4, 5, 6, 7. 7 tuples in the output. Remember, ultimately, this hostel we are projecting. Ultimately, we are projecting hostel, but there will be 7 tuples. I hope this point is clear. So remember, for the SQL query, there will be 7 tuples. There will be 7 tuples in output. Okay, actually the output will be what? If you look at the actual output, the output will have only hostel. We are only projecting hostel. Okay, you can easily see we are projecting hostel. This hostel we are projecting. So there will be 7 tuples. Now you can see the hostel number we are projecting. So because of 2369, this 7 will come. Okay, this 7 will come. Next, because of 2581, this 6 will come. This 6 will come. Next, because of 2643, because of this 2643, 2 times 5 will come. Okay, 2 times this 5 will come. Next, you can see because of 2872, another 5 will come. Another 5 will come. Next, you can see 2926, another 5 will come. Next, you can see 2959, this 7 will come. Okay, so you can see 7 tuples. You can see there are duplicates also. So there are 7 tuples. You can see there are many duplicates. Yes or no? If you notice, there are many duplicates. Ultimately, there are 7 tuples. That's it. So SQL query is giving us 7 tuples. Now let's see what this relational algebra query is giving us. What this relational algebra query will give us. Remember, S is student table and this H is hobby table. Okay, this S that is student table and this H that is hobby table. So let's see this. What we are doing here. Okay, notice what we are doing here. Look at the parenthesis. Look at the parenthesis. This parenthesis is matching with this parenthesis. So first you will do this. Okay, first you do this. This parenthesis is matching with this parenthesis. So first you do this. Then tell me what will happen. From the table S, please notice, from the table S, marks should be more than 75. Marks should be more than 75 and roll number more than 2000 and less than 3000 from the table S. So from the table S, marks should be more than 75. Marks should be more than 75. So this tuple will be gone. Okay, because marks is not more than 75, this tuple will be gone. Okay, the remaining tuples. Now from the remaining tuples, remember, roll number should be more than 2000, less than 3000. Okay, less than 3000. So this tuple will be gone. More than 2000. So this tuple will be gone. Roll number should be more than 2000, less than 3000. Okay, yes or no? So that's it. Now, after this, what you are doing? After this, you are doing the cross product followed by this roll number. So then you are joining, yes or no? Then you are joining. Basically, you are doing the cross product with H. Okay, this table, you will join with this table. Okay, you will do the cross product and then this condition. The condition is that roll number must be same. Okay, roll number must be same. Then you are projecting the hostel. So if you notice, the output will be what? Basically, the duplicate tuples will not be there. Yes or no? Everything is same as SQL query. Yes or no? Everything is the same as the SQL query. The SQL query and this relational algebra query, they are very similar. Okay, they are very similar. But what will happen? Here in the output, you will have hostel. Here in the output, duplicate tuples will not be there. Okay, in the previous output, there are duplicate tuples 765, 765, and then you can see. But in this relational algebra, there will be no duplicate tuples. So you will have only 3 tuples. Only 3 tuples. 765, because there will be no duplicate tuples. In relational algebra, we have no duplicate tuples. So only 3 tuples in the relational algebra query. Okay, is this clear? When you execute this query, only 3 tuples will be there. So the difference is what? Here 7 tuples and here 3 tuples. The difference is 4. So the answer will be 4. The question is asking what is the difference? Okay, so the for this question, the answer will be option B. Is this clear? So SQL will give you 7 tuples and relational algebra will give you 3 tuples. So the answer will be option B. Okay, this is the difference. Is this clear? Let me know. So far, all the questions, are they clear? Please tell me. So that's enough for this session. In this session, a lot of gate previous year questions we have done from the relational algebra topic. Please tell me, did you understand everything? Did you understand every gate question that we have taken in this session? Did you understand the complete analysis of each gate question? For every question, I have given you the complete analysis of each option. Option A, B, C, D. For every question, I have told you what every option means, what each option means. Okay. So I hope you understood. So thank you everyone. Please like and comment, and please share your feedback in the comments. Okay. Did you like this session? Did you like the complete analysis of each question? We have done two TIFR question also. Those were also very nice question, and some gate previous year questions we have done. Okay. Thank you everyone.